Okay, so for sine and cosine graphs, now the graphs are going to be, what we're basically doing is we're taking the unit circle that we had back here, and instead of this being on a round circle like this, we're actually going to put it on a number line. So we're going to show you how to kind of get through that and to do what it's going to be. All right, and the two graphs are really similar. The only big difference between the two graphs we're going to do is where they start, really, it comes off of. All right, and for sine function, it's going to be one of two things. It's either going to be a times the sine of b theta, and I think we talked about theta a little while back. Maybe we did, maybe we didn't. Or y equals a times the b sine x. So it's either at the end of it, either going to give you this theta or x. And again, that looks like an O with a slash through it. That's the Greek alphabet. That's theta that we're looking at. Okay, and the big thing we're going to get from this one is that A and B, the numbers we get here, that A, if you do the absolute value of A, that's going to be the amplitude. And when they talk about the amplitude, that is the your height from zero. All right, there we go. So when I talk about A, that's the amplitude. Amplitude is if you start, basically it's saying it's like if you start at zero, how high would it go? Now with sine and cosine graphs, it's also going to have negatives with it too, but it's your height from you that you've got from zero when you go through this thing. Okay, the B value by itself doesn't really do anything, but B is the number of cycles. And when you think about the number of cycles, that's one pattern, one trip around the unit circle. When I talk about the number of cycles, that's one pattern. That's us going around the unit circle one time, basically, is what that one's doing. And if you remember, like some of the problems we had when we were doing this one, that instead of finding like 3 pi over 2, we had to find like 13 pi over 2. So that's where we just kept going, around and around and around and around till we counted, 1, 2, 3, 4, 5, 6, and we counted until we got to 13 pi over 2. Okay, but the big thing we're going to get from the B in this case is the period. And the period is 2 pi divided by B. And remember, 2 pi, that was one trip around the unit circle. So when we talk about the period, which is 2 pi over B, that's basically your horizontal length. So if amplitude is your height from zero up or down, it's vertical. When we talk about the period, that's your horizontal length. Which again, if we're thinking about this thing being on a circle, really that's circumference. Okay, so A is the amplitude, or the absolute value of your A value is the amplitude. That's your height, basically, of the graph that we're looking at from zero. B is the number of cycles. That's one trip around the unit circle, basically. And then the period is 2 pi divided by B. So that's going to tell us how long we're going to stretch this graph out. That is 2 pi over B, yes. Okay. And then the one big thing you want to kind of have in your notes for this one, when we're doing the sine graph, is that your sine graph starts at oh yeah, it's just a comma. All right, and this is where we're going to kind of back up to the unit circle, and this is why we worked on the unit circle a little bit for these things. If we're talking about the graph, if we start back at 0, what's our sine value when we go back to 0? What's the sine value at 0? You remember which one's which? Which one's cosine? Which one's sine? Yeah, cosine would be your first number, so sine is your second number. So in that case, it's going to start at 0. So when we're doing the sine graph always starts at 0, because if we do the sine value on anytime we're doing with the unit circle, we always start at 0, which is our sine value. So for these, we're always going to start at 0 when we do these sine graphs. Okay. Okay, so what we're going to do is we're going to have just a basic kind of graph that we have here, and we'll show you everything that's on this graph. Okay, so when we do this basic graph, this is what it's going to look like every single time. Now, it's going to tweak and change just a little bit depending on some of the numbers, but pretty much the basic graph is going to look like this one. Okay, so here's what all the graphs will look like. Whatever this A value is, we get out of the graph up here. We're going to put A at the top. We're also going to put a negative A basically at the bottom of the graph. And that's the amplitude. You can either go up to get the amplitude or down, but we're always going to take absolute value to make it positive. And the 2 pi over b that we get here, that's going to be the last number that we're going to have there. And we said the sine graph always starts at 0, so we're going to start at 0 here. And here's where we're going to kind of use our unit circle to get us through the rest of this thing to kind of see what's going on. Okay, so if sine is the second number in our ordered pairs here, we go from 0 to 1/2 to square root of 2 over 2 to square root of 3 over 2 up to 1, right? So if we're doing sine, this number is getting bigger because we've got a half, 0.75, it just kind of keeps getting up towards the top on this case. So this one, the first thing it's going to do is go to the top. So this is kind of like your 90 degrees. So if you want to think about these, this is like 90, this is 180, 270, 360, that kind of thing. So once we get to here, this is at the top. And then once we keep working, the sine number keeps getting smaller till we get back to 0. So then we're going to come back to 0 at 180. If we go to 270, the sine value is going to be -1. And then eventually it's going to bring us back to 0. Sure. So every single sine graph will look something kind of like that. Okay, now the hardest thing that we're going to have to do for this one is that when we're going through these, we've got to kind of find out what these other numbers would be here. And for those, we'll kind of show you on the next part, because if without actual numbers in this thing, it's kind of hard to see exactly how it goes. So we'll actually give you one with specific numbers and show you how we're going to find this part of it, just to make it do everything that's here. All right, so let's give you an example, show you what this thing looks like, and then see how this thing is going to work out here. So we're going to graph y equals 4 sine x. And then we're also going to find the amplitude, which we'll just call it the amp for short. And then we're also going to find the period. All right, now what I should have done, I should have these directions off to the side. So for this one, all you got to do when they give you this equation is you've got to figure out what the A and the B are. So we're going to take this thing and go back and write this right underneath it so we can see what it is here. Okay, so that's the question we've got. This is our formula that we're looking for. So basically, we've got to figure out what the A and the B are going to be for this problem. Okay, A value should be really easy, right? So we've got A is basically the number that's in front of sign, so that part, the A would equal 4. Okay, the B in this case is going to be the number that's in front of X in this thing. Okay, for the B part on this one, there's not a number in front of X, right? But if there's not a number in front of X, what's the understood value that B would be there? Be 1, right? Because it's sine of basically 1x. So if there's not a number there for the B, just kind of know that case the B would just be 1. Okay, so for the amplitude, actually I'm gonna run out of room here, so I'm gonna do this I'm gonna skip down the next page. I'm gonna slide the page down here. All right, so for the amplitude, it's the absolute value of 4, which is just 4. No big deal there. For the period, that is 2 pi over b. In that case, our b is 1. So it's 2 pi over 1. And again, if it's over 1, that doesn't really change anything. So our period is just 2 pi. So amplitude is 4. And the period is 2 pi over b. So that's just 2 pi over 1, which is just 2 pi. All right, and whatever this A value is, that's the top and the bottom of the graph that we're going to do. Okay, and this part that was the period, the 2 pi, that's the last number that's going to go here. And every single time when we do one of these graphs, again, sine graph always starts at 0. And then we're going to go, now think about kind of like an elevator. If you get on the elevator at the ground floor, if you're going to the top, you're going to get there. And then once you get to the top, what's on the way you can go once you get to the top? Got to go down, right? So before you can get to the basement, you got to go past the ground floor, and then you can get to the basement. And then once you're at the basement, there's only one way to go, and that's back up.
Okay. Can you explain it again? What?
Yeah. Okay, so sine graph always starts at 0. So we're always going to start right here every single time. And if you notice on the unit circle, on the sine graph, it goes from 0 to 1/2, square root of 2 to square root of 3, and eventually it just keeps getting bigger until we get up to 1. So this one is where it's going to grow. It's going to grow to 1. And once you're at the top of the unit circle, what's the only way you can go from the top of the unit circle? Yeah, you got to go down. So then we're going to go back to 0, which is here. And eventually it's going to take us down until we get to the bottom that's at -1. And then once we get to -1, then it's going to start going back up towards 0. So every single time it's going to follow that same pattern. We're going to go up to the top, back to the middle, to the bottom, and then back to the middle.
But not all the answers are going to look like that, right?
Now, what? Yeah, they will. But what they'll do is sometimes with this is they may squeeze the graph in a little bit, or they may stretch it out a little bit wider. But it's always going to have that same pattern. It's always going to start here, going to go up to the top, back to the middle, to the bottom, and back there. So you know the basic shape of every single graph we're going to do for sine. Okay, now here's the hard part that we got to get to. And some of these are easier than other ones, but we'll go through this one. This one. The hardest part really on these, and going back to your question there, the graph will always look like that. So you know the graph should always look something like that. The hard part is going to be finding out what these three numbers are that are right here. Okay, and to get those three numbers, here's what we're going to do. It's all got a key on the first number. So to get the first number, you're going to take this number we got here for the period, this pi that we got, 2 pi in this case. We're going to divide it by 4. Because we got it cut into 4 pieces to get this thing. So we're going to take whatever the answer is we get here for the period, which is 2 pi over b. We're going to take that number and divide it by 4. So in this case, the first number is going to be the period, which is 2 pi, and divide it by 4. Okay, now here's the good part for this one, and this is going to be the case every single time when we're going through these. Okay, and if it's 2 pi over 4, if that was a fraction of 2 pi over 4, how could you simplify that fraction?
2.
All right, divide them both by 2, which would make it 1 pi over 2, right? Which, again, if it's 1 pi over 2, we don't really know that. We can just make it pi over 2. So that's going to be our first number here. That's going to be pi over 2. Okay, now here's kind of the neat way this is going to work out every time we do this one. And this will be the case for the problems we do. If the first number is 1 pi over 2, anybody want to take a guess what the second number is going to be? Yeah, there we go. It's going to be 2 pi over 2. The 2's will cancel and means that will just be pi. To get the third number, anybody want to take a wild guess? 3 pi over 2. In that case, 3 pi over 2 doesn't simplify, so we'll just leave it as 3 pi over 2. So it's always going to be the same thing, that once you get the first number, it's going to be 1 pi over something. The next number is going to be 2 pi. The next number is going to be 3 pi. The only thing that's going to change is what this something is down here. Sometimes that's 2, sometimes it's 4, sometimes it's 8, sometimes it's 1. But it's always going to be a 1, 2, 3 situation where you just go back and do that. And some of these, the numbers will simplify. Some of these, they won't. So this one, we got 1 pi over 2. This one's 2 pi over 2. The 2's cancel, we get pi. So then that's our 3 numbers we're looking for here. Okay, and that's honestly going to be the hardest part of what you do on this one, is getting that first number. But once you get the first number, it's easy, because then it's just 1, 2, 3 after that. Okay, we'll do 2 more of those, just so you kind of get a feel for what's going on with it. And then we'll show you cosine graph, which is really similar to the sine graph. And then that'll be all we've got to do today. So 2 more examples of this. We'll show you cosine, do 2 examples, and then we'll wrap this thing up. Okay, everybody good? Anybody else need anything there? All right, so for example 2. Let's do equals what? All right, let's do 1/2 times the sine of 2 theta. Okay, so again, we're pulling from y equals a times the sine. In this case, we're using theta, so we're going to go b theta.
I think you're doing this math.
Okay, so the a is 1/2. and the B is 2. Okay, and again, amplitude, really easy from that one. It's just the absolute value of 1/2, which is still just 1/2. It's not going to change anything. And then for the period, that is 2 pi over B, which is 2 pi over 2. 2's cancel. That's just pi. Okay, so finding the amplitude, finding the period should be pretty easy because the numbers are usually pretty, and again, amplitude is really easy. It's just if this number is positive, it stays positive. If it's negative, we'll change it to a negative. We'll show you that one next. And the period is just 2 pi divided by whatever this B number is. Usually it's going to cancel out like this. So now we've just got that this is 1 pi. And going back to Olivia's question, the graph will always look the same every single time. Now, it may be a little narrower, might be a little bit wider, but it's always going to have the same thing as far as how the graph looks. For sine is that it's always going to start at 0, going to go to the top, to the middle, to the bottom, and back to the middle. So it's always going to go middle somewhere else, and then middle is just getting top and bottom mixed in on that part. So again, we're just going to connect the dots, make it curve so it's not straight. And there we go. Top is going to be positive 1/2. Bottom is going to be negative 1/2. Okay, and this period, this 2 pi divided by B, that's the last number that's going to go here. Okay, now here's one where that kind of works out kind of nice for this one. We've got to get the first number here first. So the first number is pi divided by 4. But there's nothing else there, right? So if it's pi over 4, you can't simplify that one. So that just stays pi over 4. But again, technically that's 1 pi over 4. The second number is going to be 2 pi over 4. But if you have 2 pi over 4, you can make that 1/2. So that's really going to be pi over 2. So second number is 2 pi over 4. Third number is going to be 3 pi over 4. And if it's 3 pi over 4, that doesn't simplify, so it would just stay just like that. Okay, sometimes some of the weird things they'll do is instead of giving you these with whole numbers, they might make them out to be decimal numbers. So that may be the kind of tricky part that you might have to go back and change that into like decimal numbers a little bit just to kind of, keep it straight there. But the graph should always be the same thing. It's going to go top half first. Basically, it's like the unit circle, like you cut it open, so you do the top half of the unit circle and then do the bottom half of the unit circle. Okay, now the only time the graph won't look exactly like that with that same kind of shape to it is if you get a problem like this. And this will be the last one of the signs that we'll look at, and then we'll look at cosine, and then we'll wrap this thing up. Okay, everybody good? Still got a few people. Okay, for this one, we're going to go -3 times the sine of 8x. Okay, and I don't think we have to write the equation underneath it, so we can get this really easy. So a value is -3. B value is 8. So the amplitude is the absolute value of -3, which means the amplitude is just 3. All right, period is 2 pi over B. So that is 2 pi over 8. And if you've got 2 pi over 8, you can divide them both by 2. So you make that pi over 4. Okay, so when we graph this, here's the only time the graphs won't look the same. And here's why the graph will look different. If your a value is negative, y'all remember when we were doing like when we did graph x squared? If the a value, if we put a number in front like it's 2x squared, we knew the graph was going to go up like this. What happened if we made that a negative 2x squared? Which way the graph go? So if we were going back to graphing like x squared, how we had the parabola and it was shaped like this, what happened if that number in front was negative? Which way did the graph go? Yeah, went the opposite way, went this way, right? So instead of the graph going up, the graph went down. Same thing for the sine graph. If the a value is negative, instead of going up, you got to go down first. So now we're still going to start at 0. We're going to go down, back to the middle, to the top, and then back to the middle. Okay, and the a value is still the top and bottom of the graph, so it's still going to be the top at -3, bottom is still going to be -3. So that's the only time you do it different, is that if the a value happens to be negative, you've got to go down first instead of going up. Okay, the pi over 4 is still the same. So that one's good to go there. All right, and to get the first number, here's going to be a trick on this one because we're still, now this one's a fraction. It hasn't been a fraction before. So it's going to be pi over 4 over 4. Okay, if it's pi over 4 over 4, here's the shortcut we're going to do. You can just multiply these two denominators together and just make it pi over 16. So again, first number is going to be 1 pi over 16 or just pi over 16. Second number is going to be 2 pi over 16. But if we've got 2 pi over 16, we can simplify that and make it 1 pi over 8 because we can divide them both by 2. And then our third number is going to be 3 pi over 16. And that one doesn't simplify, so it'll just stay 3 pi over 16. So we've got pi over 16, 2 pi over 16, 3 pi over 16, but that one that's 2 pi over 16 will simplify. Do we have that? Okay, so the big thing we got to think about this one, we're doing the sine graph. Sine graph starts at 0. When we do a cosine graph, big difference on it and the sine graph is that the cosine graph starts at whatever the a value is going to be. So sine graph starts at 0. Next, we're going to look at 2 cosine graphs, and then we'll wrap this thing up. Cosine graph. Now, as far as how it works, everything's exactly the same. The only difference is for cosine graphs, you're going to start at the a value. Okay, and how it looks, the only difference is, again, you're going to take out sine, you're going to put cosine here. It looks exactly the same. So it's either a cosine bx or A cosine B theta. Okay, we're going to show you the two graphs you get. Show you one, and it's kind of the same thing. If the A value is positive, you get a graph that looks this way. If A graph is negative, you get one that looks a different way. And so we'll look at those two graphs so we can see what they. So we'll do two examples. Let's do. Actually, I'm going to put this on the next page. I'm going around the room here at the bottom. All right, so let's do y equals 4 times the cosine of 1/2 x. Oh, yeah. So again, the only difference between the sine and the cosine is one time you're going to have cosine, one you're going to have sine. Sine graphs, you're going to start at 0. The cosine graphs, you're going to start at the A value. So if A is positive, you start at the top. If A is negative, you start at the bottom. So either you get a graph that looks like this for where A is positive, or you get a graph that looks like this if A is negative. So you either get a bowl or you get a mountain, one of the two. Okay, so we'll do one graph of each one and just let you see kind of how it works. Everything works the same. Only thing that's going to change is, again, just where you start. Either you're going to start at the bottom or the top. With sine, you always start in the middle of the graph. And sometimes when they talk about starting in the middle, they're going to say that's the midline. That's another vocabulary term they'll throw at you a little bit when you go through these. Okay, so here we go. Now, it's got a fraction in it. It's 4 times cosine 1/2 x. Don't let the fraction bother you. It's still okay. You're still going to be fine. Okay, everything's still the same. That's still your A value. That's still your B value. So the amplitude, still the absolute value of 4. So the absolute value, that's still just 4. For the period, this is going to be a little sneaky because it's 2 pi over 1/2. Okay, and here's where we take you back to middle school again. I know we don't like going back to middle school, but for the period, it's 2 pi over 1/2. We're going to keep it. We're going to change it, and we're going to flip it. So that becomes 2 pi times, flip the 1/2 to make it 2 over 1. So that's 2 pi times 2. That makes it 4 pi over 1. But if it's 4 pi over 1, we can just leave it as 4 pi. Okay, so everything still works the same thing. Amplitude is still the absolute value of this number. To get the period, it's 2 pi over the B value. Just gave you a fraction. But again, even in this case, the fraction wasn't bad after do the keep, change, flip. All right, still going to look the same kind of way. Still going to have 1, 2, 3, 4 marks on this thing. The period was 4 pi. So that's that last number that will be there. Still going to go from positive 4 to negative 4. So again, the setup on it, everything's the same way. The amplitude's top and bottom of the graph. One's positive, one's negative. Still do 2 pi over b to get this. That's the last number here. But the big difference is if we're doing cosine, whatever this number is, this is where we start. So that's the big difference for cosine is we're going to start at positive 4. And if you're at the top, what's the only way to go if you're at the top? Got to go down. And before you can get to the basement, you got to go through the middle. So we're going from the top to the middle to the bottom. And then once you're at the bottom, then you got to turn and make your way back up. So we have a grand again. You just got to make it kind of loopy as you go through this one. So that's where we're going to get our bowl shaped thing out of this one. Okay, now here's where, and I know we had the fraction. Most time y'all don't like fractions. This is one where it actually works out pretty nice. Because if you need to get the first number, that's going to take the 4 pi and divide it by 4. But what's 4 pi divided by 4? Yeah, it's just 1 pi or just pi, right? So if the first number is 1 pi, the second number is going to be 2 pi. Third number will be 3 pi. There you go. So that one works out really nice because the first number was just 1 pi. Second number is going to be 2 pi. Third number will be 3 pi. Fourth number will be 4 pi. Now, we're going to do this one little piece of it. If you were to keep this thing going, which the sine graphs, they actually keep going and going and going and going, this thing would just keep repeating. The next time you get to 5 pi, you'd be here. If you went to 6 pi, you'd be at the bottom. 7 pi, you'd be back to the middle. 8 pi, you'd be back to the top. And this thing just keeps going and going forever. So we're only looking like one little piece of it. But if you kept going on this thing, it would just keep going forever and forever and forever and forever and forever as you go through that thing. But we're only going to do just that little piece of it that stops after that part right there. Once we get to the period, we're going to stop after that. But it does keep going forever. Same thing for the cosine graph. If you kept this thing going, it would just keep going and going and going. And the sine graph just keeps going and keeps going and keeps going forever. All right, one more and then we're done. Let's make it -8 times the cosine of, let's go with 2 theta. All right, again, get the easy things out of the way. A value is -8. B value is 2. So the amplitude is, you got to take the absolute value of -8. So the amplitude is 8. For the period, that's 2 pi over b. So that's 2 pi over 2. So that is just pi.
So there really isn't a difference when there's like that 0 or x again?
Correct. So yeah, whether you got theta or x, it's the exact same thing. Just sometimes they use theta instead of using x. There's no real reason on why they do. Okay, and again, we'll set it up the same way. Top and bottom is 8 and -8. We've got the period was the pi, so we know that's going to stop here at pi. And again, the big difference is if you do cosine, this tells you where to start. So cosine, you need this telling you where to start. If it's sine, you know you always start at 0. So this one, we're going to start at the bottom. And if you start at the bottom, there's only one way to go that you're going to go up. So before you can get to the top, you got to go through the middle to get to the top. And once you're at the top, then you got to work your way back down, back to the middle, and then back to the bottom. Okay, and again, the hard part is figuring out what these numbers are in the middle. So for the first number, that's going to be pi divided by 4. But if you do that one, there's nothing to cancel. So for that one, that's just our number. That's just 1 pi over 4. So it's just pi over 4. Second number, going to be 2 pi over 4. Third number is going to be 3 pi over 4. So again, first number is 1 pi over 4. Second number is 2 pi over 4. Third number is 3 pi over 4. But again, if you've got 2 pi over 4, that will simplify and make it.
How did you get the 4?
Pi over 2. Oh, that to get from the period back to the first number, you always divide by 4. Take whatever this number is, it's the period, and you always divide that by 4 because we're going to cut it into 4 pieces. So that's just like we did back here. We took 4 pi, which was this number, we divided it by 4. So to get the very first number, you always take your period, which is the 2 pi over b. After you get that number, then you divide it by 4 to get the first number.
I thought whenever you're trying to find the second number, you've been doing 2 pi over.
Okay, so then we've got 2 pi over 4, which was pi over 2, and that was just 3 pi over 4.